Welcome to the structure analysis one. We are going to start our new chapter as a strain energy, in which we are going to study elastic energy, strain energy due to gradual loading, sudden loading, impact loading, shock loading, shear loading, bending or flexure, torsion, and example of particular theories. What is elastic strain energy? We all know strain is equal to change in volume or change in dimension divided by original dimension. The difference between that is strain. And we know that the energy is any work done to any body. It's called energy. Let us see what is elastic strain energy. When a body is subjected to gradual or sudden or impact load, the body deforms and work in done upon it. The material behaves like a perfect spring and oscillates about its main position. If the elastic limit is not exceeded, this work is stored in the body. This work done or energy stored in the body is called strain energy. Strain energy is equal to work done. Let us again see the definition. Elastic strain energy. When a body is subjected to gradual or sudden load, the body deforms and work is done up to upon it. मतलब કોઈ પણ બોડી ઉપર ગ્રેજ્યુઅલ અથવા સડન લોડ એપ્લાય કરવામાં આવે તો એ લોડ ના લીધે બોડી ડિફોર્મ થાય. તો આ ડિફોર્મ થવાનું રીઝન એના પર કઈક કાર્ય થયું એ છે. બરાબર. The material behave like a perfect spring and oscillates about its main position. કોઈ પણ મટીરિયલ હોય એ ઇલાસ્ટિકલી બિહેવ કરવા માંડશે. એટલે કોઈ પણ પદાર્થના પ્રેશર આપીએ તો એ એની જે ડાયમેન્શન ઓરિજિનલ ડાયમેન્શન હતી ત્યાંથી ખસી અને આપણે જે પ્રેશર આપીએ છીએ એ ડાયરેક્શનમાં ઓસિલેટ કરશે. બરાબર. If the elastic limit is not exceed, this work is stored in the body. એની એક કેપેસિટી કરતા વધારે વર્ક ના આપી દઈએ તો ત્યાં સુધી એ વર્ક એનામાં સ્ટોર રહેશે. This work done or energy stored in the body is called strain energy. એટલા માટે strain energy is equal to work done. As soon as the load is removed, the strain energy will be given up. The material behaving like a perfect spring. However, if the elastic limit is exceeded, the work done during non-elastic strain is spent in overcoming the cohesion of the particles of the material, causing them to slide one over another, and the energy expended appear as heat in the material strain. Resilience. આ બીજી ડેફિનેશન છે મહત્વની. રેઝાઇલન્સ. Total strain energy stored in a body is called resonance. Okay. Resonance માટેનું ઇક્વેશન છે U is equal to sigma square divided by 2E into V, where sigma is equal to stress and V is equal to volume of the body. Now SI unit of strain energy is Newton into meter, and 1 Newton into meter is equal to 1 joule. Okay. Next definition is proof resilience. Proof resilience, maximum strain energy which can be stored in a body at least limit is called proof resilience. એનું equation છે UT. P stand for proof is equal to sigma E divided by 2E into V, where sigma E is equal to stress at elastic limit. Now, next definition, modulus of resilience. Maximum strain energy which can be stored in a body per unit volume at elastic limit is called modulus of resilience. Again, maximum strain energy which can be stored in a body per unit volume at elastic limit is called modulus of resilience. Proof resilience per unit volume is called modulus of resilience. પ્રૂફ રેઝિલન્સ નો જ એક પોર્શન છે નાના પોર્શનમાં એને ડિવાઈડ કરી દીધો એટલે એને મોડ્યુલસ ઓફ રેઝિલન્સ કહેવામાં આવે છે. નાઉ લોડ ડિફ્લેક્શન ડાયાગ્રામ ફોર સ્ટ્રેન એનર્જી. Consider a prismatic bar subjected to gradually applied load. Statically applied load as shown in figure. Let us see the figure. તો અહીંયા એક બાર લીધેલો છે પ્રિઝમેટિક બાર જેની ઓરિજિનલ લેન્થ L જેટલી છે અને એના ઉપર ગ્રેજ્યુઅલી પ્રેશર આપવામાં આવે છે જે પ્રેશર છે P જેટલું. બરાબર. શું કહે છે? લેન્થ ઓફ ધ બાર L, A is equal to area of cross section of bar, P is equal to load applied, R is equal to resistance produced, delta L is equal to total deformation, or we can also call it change in length. As the load P is increased gradually, the resistance R is equal to P is increased gradually. In order to evaluate strain energy, load, or in case of this resistance where versus deformation diagram is plotted. Load versus deformation diagram is plotted. Let us check the load versus deformation diagram. Load deformation. જેમ જેમ આપણે લોડ આપતા જઈશું તેમ તેમ એનું ડિફોર્મેશન વધતું જશે. તો જોઈ લઈએ આ 0 પોઈન્ટ છે, આ એક B પોઈન્ટ છે અને આ એક A પોઈન્ટ છે. બરાબર છે. આ P જેટલું પ્રેશર આવે છે એટલું ને એટલું ડેલ્ટા L જેટલું બી પ્રેશર અહીંયા ગાડી જનરેટ થતું રહેશે. બરાબર. શું કહે છે? At any stage when load is P1, deformation is delta 1. As increment delta P1 in load results in correction incremental deformation delta L1. Work done during incremental deformation P1 is equal to delta 1. જો આટલું કાર્ય ડેલ્ટા P1 જેટલું વર્ક થાય તો ડેલ્ટા L1 જેટલું ડિફોર્મેશન થાય. P1 જેટલું કાર્ય થાય તો ડેલ્ટા L1 જેટલું ડિફોર્મેશન થાય. તો શું કહે છે? The total work done is given by W is equal to sigma 0 to delta L P1 into delta 1. બરાબર છે. Now the strain energy mu U is equal to work done by the load. So U is equal to W is equal to del 0 to delta L P1 into delta L1. When load deformation is within elastic limit, the diagram will be linear. Line OA. Let us see the line OA. which is the line OA, O and A. Okay. પછી શું કહે છે? So U is equal to W is equal to 1/2 into load into deformation. In short, load into perpendicular distance. That is delta L. But we know that the delta L is equal to PL upon A. Okay. That's why we can take P square up into L divided by 2 into A into N strain, which is strain energy due to gradual loading. Okay. And we can say that U is equal to 1/2 into stress into strain into volume. Okay. We can complete our lecture at this point, and we can further next to the inelastic and strain energy and equation. Strain energy stored in prismatic bar under its own weight and some other theories.